The introductory material, and we have a feel for the model of the atom. We went through isotopes and what atomic mass is. I alluded to counting by weighing in the atoms, ions, and isotope slides. So now we're going to get into the quantitative, the math part, and when you might want to review dimensional analysis and significant figures and all of the stuff we did early on just about problem solving, because now we're going to apply that problem solving to some major chemical principles that you're going to use throughout your career as chemists. And this is the concept of the mole, and it has nothing to do with the subterranean creature. This may take more than one set of slides. More than one video. There will be 2 sets of slides over this material, and this material is on homework 4. All right, so quantitative chemistry is the how much part of chemistry. And the problem we have in chemistry, which again I said in the slides on atoms and isotopes, is that we want to know how many atoms are in a sample, but atoms are too small to see. They're on the order of 10 to the minus 10th meters across, which is really, really small. Okay, it's like a millionth of a millimeter. It's even smaller than that. And of course, also because they're so small, even in a very small sample, there's too many of them to count. And just for example, you know how theoretically to count to 10,000, but do you really think you could count out 10,000 of something? No. And of course, this is going to be much, much more. So what do? Again, if you remember the paperclip demo, we can count by weighing. And that's the idea here. We're going to use the atomic mass, and I'll show you all that. And of course, what's really, really powerful about this is weighing something using a balance is one of the easiest things that you can do. All you have to be able to do is read numbers and put something on a balance. And so it's a very, very easy measurement. Our balances go to 4 decimal places on a gram, so you can get extremely precise. And as we progress through this semester, we're going to find other ways to count atoms by making very, very simple, easy, and precise measurements. All right, so the concept is the mole concept, and it was determined by Amedeo Avogadro. You can see the bags under his eyes. It looks like he's pretty tired from counting a lot of atoms. But a mole is this many, 6.022 times 10 to the 23rd. And that is a number that you're going to need to memorize, but quite frankly, I think that by the time you're done with homework 4, you will have put it into your calculator enough times that you won't need to actively memorize it. You will have it. It's also very important. You might want to review how to do scientific notation on your calculator, because you're going to use this number a lot, and you're going to get some weird numbers if you're doing something wrong. It'll show up very quickly. This number is called Avogadro's number. Right? Now, for whatever reason, this really confuses people, but it really shouldn't be confusing because you're used to words that mean numbers. So the word dozen means 12, a pair is 2, a gross is 144. A mole is 6.022 times 10 to the 23rd. And by the way, we abbreviate MOLE, MOL. And again, just to review, Avogadro's number is this number. Right, and the symbol for Avogadro's number is capital N subcapital A, and we make a big deal about units. Avogadro's number has no unit in the numerator, it's just moles in the denominator, so it's whatever per mole. All right, so a mole is a mole is a mole, so a mole of marbles would be Avogadro's number of marbles. A mole of grains of sand would be 6.022 times 10 to the 23rd grains of sand. So a mole is, just like a dozen, is 12. So if this bothers you, substitute the word dozen and 12. It's literally the same concept. For chemistry, a mole of atoms is that many atoms. A mole of molecules, 6.022 times 10 to the 23rd molecules. A mole of ions, Avogadro's number of ions, and so on. So in general, I use the word particles because all of these are types of particles. Atoms, molecules, and ions are all particles. So it's particles per mole. Right? And you'll see how the units play out later. Another concept is molar mass. So we talked about atomic mass. Remember the average of the masses of the isotopes. So molar mass for an element is called the atomic mass, which you get from the periodic table. On this one in particular, it's kind of hard to read just on the slide. But again, I've given you a periodic table in this on the Canvas site, so it's a good idea to print that out, have it handy. Right, because you don't need to memorize atomic masses, but you should look them up. Molar mass of a compound is called molecular mass or formula mass, and these are calculated, and we'll deal with this a little bit later on as we progress through this set of slides. All right, so just to help you understand a few things, so a mole of iron is Avogadro's number of iron atoms, and it's 55.847 grams of iron. All right, and again, if you back up, if you look up iron here, it's kind of hard to read, but that 55.847 comes from the periodic table. For carbon, a mole is this many atoms, and again, going back a slide, carbon, 12.011. Right? Sometimes your periodic tables might not give you as many decimal places. That's okay. And so you could put all of these per mole. So atoms per mole, grams per mole. It's a good idea because this is the first time you're doing this. This is where you're going to create habits to get in the habit of not just writing grams per mole, but grams of iron per mole of iron. Don't just write atoms per mole, but iron atoms per mole of iron. And you'll see as we go through this, one of the very last slides here is the first time you'll see that, but as you progress in chemistry, you're going to have moles of several things, and if you just write moles, you might get confused as to which is which. So dimensional analysis is used best if you're very, very diligent about labeling things. So not just grams, but grams of what? Not just moles, but moles of what? It'll save you hundreds of points throughout your career in chemistry just because of all the mistakes you won't make if you do that. So let's do some mole calculations. We're going to go through 6 of them. And you can hit pause and try these on your own, but I'm going to go through them. All right, so the first calculation we're going to do, how many moles of carbon in 1.65? They always do this when I'm making a video. How many moles of carbon in 1.65 times 10 to the 25th carbon atoms? So this is where you're going to use dimensional analysis. So the first thing you want to do is write down the units of the answer. So the answer is going to be moles of carbon. In this case, we only have one number, so we're going to go from carbon atoms to moles of carbon, and then we need the relationship between them, and the relationship between atoms and moles is Avogadro's number, and in this case, we want atoms to cancel. Oops, I don't have that as a superscript, but that's okay. But we have 1.65 times 10 to the 25th carbon atoms times 1 mole of carbon for Avogadro's number, and that's moles of carbon. I'll fix this, I'll clean up the slide when you look at the slides, but the video is going to look like this. And so I'm developing a rubric over here, so what this problem shows you is you can go from particles to moles using Avogadro's number, right? And from atoms to moles using Avogadro's number. All right, we'll do another one now. So we're going to go from, we want to go from moles to atoms. How many sodium atoms in that many moles of sodium? So again, hit pause if you want and try it by yourself. That's why I'm stopping for a second. So the first step is write down the units of your answer. The answer is going to be moles of sodium. It's a good idea to get in the habit of using the symbols. And of course, we're starting with 0.0306 moles. So in this case, we want moles on the bottom. All right, so moles of sodium are on the bottom. For whatever reason, the superscript doesn't want to show up here. All right, but make sure you can do the math. And on the last one here, this previous slide, make sure if you do this math wrong, if you put this in your calculator wrong, you're going to get like 10 to the 48th. And so if you're getting that answer, you're putting Avogadro's number in your calculator wrong, and you can pop up on a Zoom session. I'll walk you through it. I did show you in a very early set of slides how to do that on your calculator. All right. And so this slide shows that you can go from moles to particles using Avogadro's number. All right, now let's go how many moles of scandium in 16.25 grams of scandium. Okay, so again, you can try it on your own. Let me go through it. So we want the units of the answer to be, that's right, we want moles of scandium, and scandium is Sc. And that means we're starting with the grams. So now we need grams on the bottom. And so what we're going to relate, the relationship between grams and moles is the molar mass. So where did I get this number? I got it right off of the periodic table. Now, as far as how many significant figures should you use, periodic tables frequently have a lot of digits. You should try to use at least one more than what you're given. So I have 4 sig figs here. I carry the molar mass out to 5. And that's what this says here. Now, what this slide shows is I went from mass to moles, and I used the molar mass. So here, mm means molar mass. So let's go the other way. The mass of 0.52 moles of cobalt So again, what will the units of the answer be? That's right. And again, get in the habit of not just writing grams, but grams of cobalt. You'll see why as we progress. And then the mass, we're going to start with 0.52 moles. So we need the relationship between grams and moles. And in this case, we need moles on the bottom. So we're going to use the molar mass. So the molar mass is always grams for 1 mole. Previous slide we had it upside down because we wanted to go that way. And then you do the math. All right. And here it showed that we went from moles to mass. So you literally can go, this is the rubric, right? You can literally go from particles to mass or from mass to particles, but you have to go through moles. They literally say the mole is the central concept in quantitative chemistry. And we're not kidding, all right? And so this is a very handy rubric if you like. I'm going to do 2 more and then we'll stop this video and we'll start the second video. All right, so try this on your own. But I'm going to walk you through it. And it's important, like I said, when you're doing dimensional analysis to ask yourself simple questions that you can answer. So we want the mass of 8.56 times 10 to the 20th lead atoms. Okay? So the units of the answer are going to be grams. And then we're going to start with the 8.56 times 10 to the 20th. Now you can work it backwards or forwards. So I'm going to do this one forwards, the next one I'll do backwards. All right, so going forwards, we want atoms to cancel, or you can go back through the rubric, right? I am in particles, I want to go to moles, so I'm going to have to use Avogadro's number. Either way, I want moles to cancel. So the atoms are here, I'm sorry, I want atoms to cancel, okay? I have moles on the top, so atoms cancel. Now I have moles to grams, so to go from moles to grams, I want moles on the bottom. So you see grams, moles are on the bottom, grams. And then mathematically, 8.56 times 10 to the 20th divided by Avogadro's number times that number, and that should give you this. Again, if you get, and this should be an exponent, it looked like it when I set it up, it's going weird on me, but the exponent should be, you should not get 10 to the 43rd or something 10 to the 44th. Make sure you get this, make sure you can get this number in your calculator. All right, I'll do one more and then we'll stop for a moment. So how many tin atoms in 56.8 grams of tin? So this one I'm going to do working backwards just to kind of show you the different ways of thinking it through, but you should do whatever you like. If you get stuck one way, try the other way. All right, so we want the units of the answer to be tin atoms because it says how many tin atoms? It's going to be that many tin atoms, and tin is SN. So we're going to start with the 56.8. So where can we get the unit tin atoms? Where can we get atoms? We get atoms from Avogadro's number, right? So now we have atoms. The atoms, again, this moved when it came up here, right? Atoms should be over here, but we get 10 atoms per mole of tin. So now we need grams and moles to cancel. So we're going to need grams on the bottom, moles on the top. And so we put the molar mass in. Gram-to-mole relationship is the molar mass. So grams on the bottom, moles on the top, and when you do the math, this is the number. All right, so I'm going to stop here because we're going to deal with formulas. Okay, I'm going to stop here on this video, and we'll pick up on the next slide on the second video.